Hey, hi everyone. Welcome to my YouTube channel. My name is Sunny Savita and I'm back with another exciting and useful video. So guys, in this particular video, we're gonna see how we can create a RAG-based chatbot with memory. Yes guys, so in my previous video, I've explained you how you can create a chatbot with memory. Now, if you want to integrate the RAG pipeline inside the chatbot, how you can do it and how you can sustain the memory over there. So my complete discussion will be around to that only, and along with the practical I'll be explaining the theoretical point as well, and at the end you will get to know how we can create these kind of pipelines. So guys, let's start, let's begin. First of all, let me show you my YouTube channel. So here guys, just a second. This is my YouTube channel. If you haven't visited so far, please go and check. I have uploaded very amazing content with respect to generative AI, and definitely it will help you to start with your generative AI journey. So this was my last video with respect to the chatbot. This one, please go and check out. Please try to learn about the chatbot, and this video will help you with respect to today's tutorial itself. And before that, I uploaded the Langchain crash course also. So yeah, both video you will get inside this particular section. If you want to learn couple of other things with respect to generative AI, so definitely you can check out with my playlist. There I kept a different kind of playlist, and soon I'll be uploading many more videos. So guys, I hope this thing is clear. Now let's start with the solution. So solution of this RAG with memory. So here guys, I try to cap the code, okay, but this code is it's a waste, right? Until we are not going to understand the architecture, until we are not going to understand the theoretical stuff related to this particular problem. Okay, so first let's try to understand the problem statement. Let's try to understand the theoretical point, then again I will come to this particular implementation. So here on my blackboard itself guys, I try to cap everything. First of all, let me remove it from here so that I can start from scratch. If you don't know about the RAG guys, I created a dedicated playlist on top of the RAG. Definitely you can check out and you can learn from there about the RAG. So this is a architecture of the RAG guys. Now before coming to this architecture, let me give you some theoretical stuff. So here, let's say what I have. I have my LLM model. Okay, this is what? This is my a large language model. Now to this LLM model, let's say I'm passing one question. Okay, this is what is my input prompt. I can write over here prompt, right? Now this is going to be my input prompt. Now what I will get, tell me guys. So I'll be getting my output. Just a second. Let me write in a uh, good way. So here is what, here's my prompt. Now what I'll be getting my output. So here is what, here's my output, right? So this kind of mechanism is called like a basic question answering. So here I can mention about it. So this is nothing, this is question and answering, right? Where I'm asking the question to my LLM and it is replying to me. Now guys, let's say if we are able to maintain, okay, we are able to maintain the history of this particular conversation, right? And if we are able to serve this application somewhere with respect to any sort of a domain, right? So this is what, this is my chatbot. So here if we are able to maintain the history of what, history of this particular conversation, right? If we are able to maintain the state like we do inside the chat GPT, so this is what, this is my chatbot. Okay, now guys, let's say sometime my LLM is not able to answer something. So let me remove this part as well. Sometimes my LLM is not able to answer something. So in that case, what we do, we connect this LLM. Okay, we connect this a large language model with the RAG pipeline. So RAG is nothing, it's a retrieval augment generation. If you don't know about the RAG, so let's understand about the RAG architecture. So what we do guys, we never answer directly. So here we are asking the question directly to my LLM. We never do it. What we do, we create the RAG pipeline. Okay, means whatever question we need to ask, whatever input we're gonna pass, we pass through this RAG pipeline. Now, how to do that? Let me show you. So this is the complete RAG architecture. So first, guys, inside the RAG pipeline, we'll be always having one database. Okay, our knowledge base. We are going to create a chunks from that particular knowledge base. Okay, and then we are going to create an embedding of that, and somewhere we are storing inside the database. This is usually this database is called vector database. Okay, now guys, let's say user is asking any sort of a question, so we convert this question into the embedding, then again it come back to the vector database, and then we perform the semantic search, or we perform the similarity search, and based on that semantic search and based on that similarity search, we find out some rank results. Rank result means what? Top result, topmost result. And here if we want to perform the re-ranking, I can do that also. It's my second level filtering. This all the thing I already uploaded on my YouTube channel. If you don't know about it, you can go and check with this advanced rag playlist. Okay, now guys, what we do, we pass this data, this complete context and all. Okay, this query, this prompt. Okay, prompt means the instruction to my model, and here is the context. Context is nothing, this is the ranked answer or retrieve answer. We pass everything to my model, to my LLM model, and finally we generate the answer. Okay, finally we generate the answer and we pass it to the user. This is my rag pipeline. So guys, instead of passing direct question to my LLM, okay, what we do, we pass some more context. Okay, using this rag pipeline. Here is a complete rag pipeline which we connect to the LLM, and then we generate the answer. I hope this thing is clear. So first of all, let's do one thing. Let's try to create this RAG pipeline, and then I will show you how you can create the history aware RAG, because that is very much important. And before this history aware RAG, guys, history aware retriever pipeline, history aware RAG, anything you can say. So we'll have to understand the complete coding of this RAG. So guys, here I kept this particular coding. Now let me show you. First of all, let me connect it. So either you can connect with a GPU or CPU, anything is fine right now, because we are not going to do very heavy implementation. So guys, here it is getting connected. So let it connect. Okay, so my system has connected. Now, what I will do, I will install the necessary library. So I'm going to install it, guys. See, and after that, after installing it, I have to set couple of variable as well. So this is my variable, guys, which I am going to be set over here. So this variable is related to the logging. So if I want to capture the log of this particular implementation, so that's why I'm defining this variable. And if you don't know about it, you can check out with this particular video, Langchain one shot video. There I have explained the use of this Langsmith. Okay, Langsmith for capturing the log of the implementation. So I can give you the glimpse of that, how basically I'm getting this particular variable. This is with respect to the Gemini. Okay, I'm using the Gemini model. That's why I kept it. Now here, these are the variable from where actually I'm getting it. So once you will go through with the Langchain website, here inside the product, if you will search about this Langsmith, so there here is a Langsmith, guys. You will get this type of interface, right? Now what you can do, you can click on this new project. Once you will do it, guys, it will give you all this variable. Now this particular variable, you have to set it as a environment variable. Okay, here you need to pass the API key. Here you need to pass your project name, whatever you want to pass. Okay, and from where you will get the API key, so just click on this setting icon. So once you will do it, guys, here it will give you the option for generating the API key. See, here you are getting it. So once you will configure all the variable, so see, I already created couple of project, and here is the complete log. Okay, log of those particular implementation. So easily you can track what is happening at which step. So if your like application is too complex, in that case you can actually you can track the complete application using this log. I hope this is clear to all of you. Now let me run it. Let me set all the environment variable, and this is my project name. So the new project will be created automatically over there. So it's saying import OS. Okay, let me run it again. Import OS. Yeah, it is working fine. Now here I'm going to be import this warning because I don't want to any sort of a warning in between my answer. So that's why I'm importing it. Now here I'm going to be load the embedding model. It is Google Gemini, but it is up to you. You can utilize or you can keep any sort of a model inside your implementation. I'm not going to stop you. Okay. Now, apart from this one, guys, what we have a model. So which model, guys? We are using this Gemini model, Gemini 1.5 Pro 001. Why I'm using it? So that easily you can access it, means like without any sort of a cost. We have other ways also. From the Hugging Face, we can take any sort of a model, we can take any type of model, but right now I'm not going for that, because my main intention to explain you the history part over here. So here I'm checking my model, whether my model is working or not. So yes, it is working. So I hope everything is set till so far. Now my model is working. Now what I will do, guys, I will be gathering the data, and on the domain specific problem, on the one specific problem statement, I'm going to implement this reg pipeline. So here I'm going to collect my data. This data basically I'm going to collect from where? From the internet itself. So for that, actually I'm using this VS4. Now here you can see we are going to import this create a retrieval chain, and here create a document stuff chain. Okay, then chroma as a vector database, we're going to use chroma. Okay, so let me run it, and here is web based loader, right? So we have web based loader. Web based loader, basically what it will do, it will fetch the data directly from the internet. Now here what I have a chat prompt template, so I can define my prompt basically, and here my recursive character test splitter, so I can make the chunks. Here is my message placeholder, so I can keep the variable inside my chat prompt template. So later on I can pass any sort of a message, okay, dynamically while I'm calling the chain. Now guys, what I'm doing, I'm going to be collect the data. So I'm going to collect the data using this particular link, and here I pass the couple of argument as well. So what I want content, title, and header from this particular data. So if you will go and check with this this link, so what you will get the data. Here it is. Let me show you that. So where it is, this one, guys. So here this is a blog, actually, LLM powered autonomous agent. It is a complete blog on top of the agent. We are not going to extract any image from here. We are just going to be extract the content. Okay, that's why I have mentioned this particular like values. Now guys, what I will do, so once I will run it, guys, I will be getting my data. So inside the doc, actually, I will get my data. Okay, doc document. Now what I'm doing, I'm passing this doc to this text splitter. See, here is a complete data. Okay, now what I'm doing, I'm passing this data to my recursive character test splitter, so I will be getting my chunks, right? And then what I'm doing, I'm going to be store this data inside the vector db, inside the chroma. So here I'm performing in memory storage. I'm keeping the data inside the memory itself. So here is my split. Okay, so this is my split. Here is my embedding. So it will take the document, and then after taking the document, it will convert the embedding, and it will be keeping inside the memory itself. Okay, those particular embedding. Now let me run it, and after the embedding, after like storing the data, guys, what I did, I created a retriever. So here is my retriever, guys. Now on top of it, basically I can perform any sort of a I can pass any sort of a query, okay, to this particular retriever, and I can generate the similar type of answer. So far what I have implemented over here, if you will go and check, so let me show you inside the architecture. So we have implemented this part. So here is my data. Okay, and from the data, guys, what I'm doing, I'm going to be perform the chunking, and after embedding, I'm storing inside the database. So this particular stage, right, I perform the data ingestion stage. Now after that, I have to generate the answer, okay, after retrieving. So this is my system prompt, guys. What I'm doing, I'm defining the behavior of the system, and here I'm here itself inside the system prompt only, I'm passing the context. So that what I'm doing, I'm passing the context over here itself. Basically based on that, I can ask any sort of a answer. All right, based on that, I can ask any sort of a query, okay, to my model. So if you don't know about it, guys, I can explain you that. So just go with the chat gpt, and here over the chat gpt, what you can do, you can define the behavior of your chat gpt. Okay, how you can define, you can write one message here. So you can say you are funny assistant. Okay, I'm saying it's a funny assistant. You can define anything. So it's a funny assistant, and you have to answer all the query in the funniest way. Okay, so this is the question. Now let me run it. So this is my behavior of this particular system. Okay, now let's say if I'm going to ask any sort of a thing, it will answer in this particular manner, inside the funniest way, right? So here I'm asking I how I can earn earn money, right? So this is my question. Now you will find out, it will answer invent a time machine, sell bottled air, tech cast, okay, create a course. So guys, see, it is giving me like sarcastic answer. It is not giving me any straightforward answer or any uh basically generic answer, right? So like this you can define the behavior of the system like this. Here also I'm doing the same thing. So previously, if you will go and check with my rag chain, you will find out this retriever actually I was passing along with a question. So in both way you can do it. Means this retriever means the context you can pass along the question, then prompt, then LLM, and final output parser. Like this also you can create a chain, or what you can do, you can pass the context to your system prompt itself. You can define as a system behavior, and then you can ask the question. So here I'm like trying to tell you the multiple ways. Okay, but at the end the main aim is same, right? To generate an answer using the LLM after giving some information to it through the RAG pipeline. Got it? Now guys, what I'm doing, so here is my system prompt which I am defined. Now here is my chat prompt template. It will take the system prompt and this input, and finally here is going to my chain model and chat prompt template. Okay, this is going to my stuff chain. I'll be creating separate video on top of this chain. We have a different type of chain. Nowadays we have a LCEL. Okay, this Langchain expression language, so we don't require this kind of chain, but again like we can use it. It's a way of connecting multiple component all together in an efficient manner, and we can create any sort of a thing, okay, any kind of like applications over here, okay, just to connect multiple component. Here I am creating a rag pipeline, okay, just to connect this particular component. So here model and chat prompt template. Now what is my next thing here? So here I'm going to pass this retriever and this question answering chain. So I have connected three things. First is what? First is model, then prompt template, and then this retriever. Okay, now finally I have to invoke it. So this is my question which I'm asking. This question actually I took from this particular documentation itself. You can take any sort of a question. Now here I'm like running this particular question, and see, I will be getting my answer. So this was the RAG pipeline. Okay, now we have to understand how we can add on the history inside this particular RAG pipeline, guys. So how this history aware retriever works? Let me tell you guys. Let me explain you that particular part. For that, I kept couple of images inside this implementation, and definitely by seeing those images easily you can understand it. So here, guys, see. This is the images. Definitely, I will explain you along with the example. I kept everything for all of you. So what we are doing? See, if you will look into the retriever part, so what we are doing, we are passing the query to the retriever, okay, and we are generating the answer, means the similar answer, and then further we are passing to the LLM, right? And you can look into this particular architecture. The idea will be more clear to all of you. Now coming to the next part, see, if we are talking about this history aware retriever, inside that we are we have a query, whatever query user is asking. This query, guys, I am passing along with the chat history to my LLM. Getting my point? And then we are rephrasing the query, and then we are passing to the retriever for generating the, tell me, ranked result. Okay, which result? Let me write over here, ranked result. Okay, so how it is working, let me explain you. And the same thing, basically I kept it inside this particular architecture as well. So later on I will come to this one. First let's try to understand with the example. So guys, let's say this is the scenario. So here I'm asking a question. Here my user is asking a question: what is a machine learning? Now here is my answer. Okay, my answer is what? Machine learning enable computer this that whatever. Okay, so I am able to generate this particular answer to my LLM. Just think about it. So here is my here my user is asking the question. Okay, this one, and whatever data we have retrieved, whatever rank result was there. Let me clear it first of all. So whatever rank result was there, based on that particular rank result, okay, we are able to generate this particular answer. Now guys, see, here what is happening second time. My user is asking one more question, and now this question, guys, it is directly related to this previous answer. Okay, so my user is asking, what is this making prediction? What's the meaning of it, right? So here, guys, see what is happening. This question along with this answer, okay, this question, this new question along with this answer, this is what, this is my chat history, chat history, right? So along with this answer, and here is what, here's my prompt. Now just read the prompt, what I'm saying. So here we are saying, given a chat history and the latest user question, whatever question user is asking, which might reference context in the chat history, means this question might be connected to this particular chat history, okay, this particular chat history. Formulate a standalone question which can be understood without the chat history, means now we are trying to formulate a new question, we are trying to rephrase the question, okay. And here we are saying, do not answer this particular question, just rephrase it, just reformulate it. Now why we are doing it, guys, here, so that we can see here guys, how we are going to rephrase this particular question using the LLM, means this question, this machine learning like answer, and here this particular prompt, all the three things, okay, all the three things combinedly we are going to pass to our LLM, and then LLM will generate the new question. And this particular question, guys, see here is a question: how does machine learning make prediction by identifying pattern in the data, and what does making prediction mean? So this particular question I will be passing to my retriever, and so this is called, guys, history aware retriever. Are you getting my point? History aware retriever means this question, okay, this question basically we got, okay, we got from the user end. From where we got it? We got it from the user end. But maybe user has not provided many more information. Whatever he want to ask, he just told over here. Okay, so see here in the question, this user is writing, what is a making prediction, right? Maybe they are not providing any sort of a context, anything over here. Let's say I can take one more example. Here I am saying 2 plus 2 is equal to 4. My LLM is giving this particular answer. Now I'm saying, what should I add so it will become 10? What should I add inside this particular answer? So 4 plus 6 is equal to 10. So here I'm not giving anything, means here I'm not giving any plus equation or something. I'm just asking the question based on my previous, right? So let's say if user is asking any sort of a question, right, if user is asking any sort of a question based on this particular history and user is not mentioning anything, how we will be able to retrieve the correct thing from the database? Just tell me. So that's why what we are doing, we have a question, we have this history, we are passing the prompt, and we are going to rephrase the question so that easily we can take the, tell me, easily we can take the similar kind of document from the database, and further we can pass it to the LLM model. I hope you are getting. And this is what, guys, this is history aware retriever, means the next question, it is connected to the previous question that we are going to rephrase using the LLM power, and we are passing to the, tell me, we are passing to the like retriever, and we are getting the relevant document. Now I hope this is clear. Now let's look into this particular architecture. So what we are doing, so here is my input query, okay, here is my chat history, this one connectively. Now we have a context like this contextualize prompt, means my system prompt. We are passing to the LLM, we are generating a new query, then we are passing to the retriever, and here is my document. Now for the further generation, what I will do, so this document I will pass along with the answer, along with this prompt, and along with this chat history will be passing to the LLM, and finally we are generating my answer. So this is the entire thing, and I hope so it is clear to all of you. Now let's look into the, guys, of further implementation. So first, guys, we'll have to import this create history aware retriever. It's a class inside the Langchain itself, so directly we can use this particular class. Okay. Now after this one, guys, after importing this class, let me import it first. Here is my retriever prompt. Okay, the prompt, the system prompt. Okay, which I told you. Here you can see the complete text of it. So I'm running it. Now what I'm doing here, I'm going to create my contextualize prompt. You can look into this particular architecture. So we are going to retrieve the answer. So if there is a chat history, if chat history exists, then only it will reformulate, it will rephrase the answer. Sorry, it will rephrase the question. Otherwise, it won't do it. And how we are doing it? We are doing it using this particular prompt. So see, I mentioned about it. Now, here is my prompt. Then what I'm doing? So create history aware retriever. We are passing the model, we are passing the retriever, and we are passing this contextualize q prompt. Now, guys, if you're not able to understand this hierarchy, let me explain you in a simplest way what is happening over here, this particular architecture. So, here, guys, actually, what we are trying to achieve. Just a second. See, whenever we implement any sort of a chain, okay, so we connect the component. So, in a component, the first component, that's my prompt. This prompt actually, it is connected to what? It is connected to my LLM. Okay, LLM. Now this LLM, what it will do? So whatever prompt, like I have defined this contextualize prompt. Let me write over here. Contextualize prompt. This prompt, it will go to the LLM and it will generate the answer. This answer basically automatically I will pass to the str output parser. If you don't know about this str output parser, of this chaining and all, you can refer to my previous video. Then what I'm doing, so here finally I'm passing to my retriever. So retriever, what it does, it will pass to the retriever and then we'll be getting the relevant document. Okay, relevant document from here. So this is the complete hierarchy, guys, which we are trying to achieve inside this chain. Okay, I hope this thing is getting clear to all of you now. See, let me execute it. Let me create this history of a retriever. Now what I'm doing, I'm creating my chain. Okay, here is what, here is my stuff chain. Okay, create stuff document chain. Now here is what, here is my prompt, system prompt, message placeholder. There is my chat history. Whatever chat history I'll be passing, it will come over here, and here is my input, means my human, means my questions. Okay, user question. So this is my QA prompt, guys. So this was the this is for what? Tell me this one. So this is for the retriever only. Okay, and this is for what? This is for the main LLM. Are you getting my point? Right? So this prompt, this particular one, this particular chain for the retriever, and now this is final one for my LLM, because at the end we have to pass it to the LLM only, na, right? So I hope it is clear. So let me create this model plus QA prompt, this particular chain. Let me delete this part. So here is my chain. Okay, question answering chain. Now everything I'm going to be combined over here. So here is my history aware retriever, means my retriever, and this is what, this is my question answering chain, means my model. So here I've combined everything, and this is my final rec chain. Now here I'm going to be import this human message and AI message, and see, this is what is my chat history, right? Whatever I'm going to be asked to my model, it will be it will come over here inside the chat history. It will save it. I will save it over here. I will show you at the end. Don't worry. Everything is a transparent inside this particular solution. So this is my question. What is a task decomposition? It is with respect to this document only. You can generate a different type of question, and you can ask to your model. Okay, this is your responsibility now. I'm just showing you with this one question only. Now if I'm passing it, so see, this is my question first. I'm passing this question first, and here is my chat history. Okay, this particular list. So message one, and I am passing. Okay, let me define this chat history. Now I am passing this message. I'm passing it. Okay, so I'm passing this chat history over here. Here is my question. I'm invoking it. I will be getting my answer. So let me, okay, a message one or answer, anything is fine. I'm just keeping inside this particular variable. Now let me show you the answer. So it is saying 500, please retry on report it. Okay, I think uh revoke. What is the issue here? Just a second. Okay, it is working now. Now here is message answer. So let me check the answer. This is the answer which I'm getting with respect to this question. Now what I'm doing, so here I'm going to add this particular thing. Okay, inside where? Inside this chat history. Okay, I'm going to call this extent. So I will be segregating this human message and this AI message, both. So here I have added. Now you can see this chat history. See human message and AI message. Now what I'm doing, I'm asking the next question. So what are the common ways of doing it? I'm not mentioning anything. Everything it need to pick from the previous answer itself. Okay. So here I'm running it and see it is giving me a answer. Again, it is generating this answer. Resource exhaust. I think there is a issue with the key maybe. I will have to generate a new one. Don't worry, I will do it after the session. So here again it is generating internal server. It was giving me when I was practicing it, na. 429 resource adjusting. Just a second. Let me run it one more time. Resource exhausting. Okay, check quota. I think quota is exceed. Let me check it, guys. Don't worry. Yeah, so it is running for me now. So here, what was the issue? Basically, I was facing. So to this, I was using Gemini 1.5 Flash model. So that particular model actually, what happened now? So I adjusted the limit in terms of what? Limit in terms of the context which we are passing over there. So if you are also facing this particular issue, in that case, what you can do, you can use any other different model. So maybe you can use Gemini 1.0, Gemini 1.0 Pro or Gemini 1.5 Pro, right? These particular model, so that you want, so that like it can bear the context, okay, in the free limit in the free uses, and easily you can test your pipelines. So now guys, I asked this particular question, what are the common ways of doing it? Now here I am passing my question, second question. Here is my chat history, means my previous conversation, this particular one, and based on that, here you can see this is the answer which I am getting. But here you will feel that everything I am doing manually, means manually I am passing the chat history, and it is not a good practice. So guys, here this Langchain has provided us a automated way. So what's the automated way? Let me tell you. So this way actually I have used in my previous session also. If you will go and check this particular session, chatbot using memory, Langchain with memory, so there also I have used this particular way. Now I'm going to import couple of statement. Chat message history, base chat message history, runnable with message history, right? Now guys, after doing it, just a second. Yeah, after importing it, I'm going to be create one dictionary store, and then this is my method, right? This method basically get a session history. So with respect to the session ID, whatever session ID I'm passing, with respect to that, I'm getting a chat history. I will let you know what is this. If you don't know, guys, what you can do, I can suggest you the previous video. Just go and check, and I can give you very good example. Here, let's say if you are chatting something, you are writing something, okay, you are generating something based on that, whatever, right? Now, see, here this is your first chat, okay. Now, let's say you have initiated a new chat. So this chat and the previous chat, both are different. Agree or not? If you will go with the previous chat, this one. So funny assistant, both are different, right? So that is what I'm telling to you. Here also you can maintain that setup, okay, using this session ID. You can mention the different chats. Okay, you can maintain the different contexts inside the single chat also. You can maintain the different sections, okay, different contexts. That is what I'm trying to tell you. Getting my point? If the conversation is going to change, you can change this particular ID. Okay, so here I'm going to create this particular, here I'm going to execute this code. So I'm getting session ID. If it is not inside the store, I have to create it, I have to keep it over there. Otherwise we have to return the conversation related to that, okay, related to that particular session ID. Now what I'm doing, I'm creating a runnable with message history. So there is my rack chain, here is my get session history, okay, this particular one, and then we have some inputs, variable input, chat history, and this answer. Now let me execute it. So here I executed it. Now I'm going to invoke this particular chain. So I'm writing conversational reaction invoke. Here is my message, and see, here is what, here is my session ID. So with respect to this particular session ID, I'm going to like keep the conversation inside the dictionary. So let me execute it, and here I can show you that. So see, it is generating answers. This is my answer with respect to this question. If you will look into the store, so you will find out this particular ID, and here is the complete conversation. Now if you are going to change the ID, this particular ID, so according to that, you will be getting the conversation. Now this is my next question. What are the common ways? And I'm maintaining a same and I'm maintaining the same session ID so that it will be captured over here, okay, with respect to this particular key only. Now let me run it, let me execute it. So yes, it is able to generate an answer based on this previous data. See, common ways of doing it, this is that, right? You can test it with a different question. As of now, I'm not doing it. Now if you want to check the complete conversation, whatever conversation I have made over here, so here you can check. See, user is asking this is the answer. User is asking this is the answer. Getting my point? Now let's say if I'm going to ask any sort of a thing, what is a prompt technique like step XYZ? Okay, I am asking the question from this particular answer only, right? So somewhere it has mentioned common ways of restarting this is okay, no issue. I am asking this particular question. Now see what is the answer which is trying to provide to me. So here I am going to write one question, one more question, and here it is giving me a answer. A prompt technique like step xyz is a this one, right? So if it is not able to find out over here, in that case it is going to return this particular question only. It is going to my retrieval, getting my point, to my retrieval, and it is fetching the relevant answer because I designed the prompt in such a way, if this question, okay, if this particular question is not matching with any sort of a answer, with any sort of a conversation, right? So here it will return it as it is. If you will look into the prompt template, now you will get it. See here, do not answer the question, just reformulate it if needed. Okay, formulate a external question without the chat history. Okay, if it given a chat history and the latest viewer question with a night, it might reference, right? And if it is not like a referencing, in that case, see here, basically somewhere we have mentioned inside the prompt itself. If you don't know the answer, you can say that okay, it will take care of it, guys, right? It will directly pass it to the LLM, it's means to the retriever itself. Okay, if it is not able to find out the previous history. Now if you will look into the conversation, so this is the complete conversation, right? Likewise, you can look into the conversation, and you can sustain any sort of a conversation, right, up to the mark. Now guys, let's say if the conversation is going to be too long, too huge, in that case what you will do, tell me. In that case, actually you will trim the message. Now how you will get to know how to trim the message? You will get it over here inside this particular video. Okay, so yeah, thank you guys, thank you for watching this video, and this is it. Now you can test with a different question and answer, and you can check whether it is working fine or not. If you have any doubt, you can let me know inside the comment section. Until the next video, thank you, bye bye, take care guys.